neural networks? Yes, this is perfect. And then I'll get into a little background on TensorFlow. Anybody use that? Okay, even better. And after we go over TensorFlow stuff, we'll get into kind of more of the live coding part or the live demo part. And we'll talk about how to decide what features to use, how you can train your model to understand like real-time user behavior, and how you can use the predictions that your model makes to update the DOM. So, to give you a little background on neural networks, they're basically just algorithms that can be used to make predictions. So, you have an equation, you give it some inputs, it gives you some outputs. That is a neural network in a nutshell. So, they're made of different layers of nodes, and basically what that means is that right here you see one node, and it has different inputs, and each of those inputs will have a different weight to show just like how significant it is for the prediction results. And in the middle, the net input function, that's what's gonna like train it and help you calculate errors and how long it takes, all that good stuff. And then you get some output, and you just have a bunch of these clustered together to make a brain. So, one thing that people try to make complicated with machine learning is what exactly stuff means. So with deep learning, it just means you have more than one node. That is it. You just have 2 or 3, maybe more, probably more than that, of nodes that look like that. And they can all use their own input and activation functions. They can all have different weights. It just depends on what exactly you're trying to model and what you're trying to use that data to, I guess, get information from. So, the way neural networks work in web development, you can use them to predict user behavior. So, let's say you want to know if a person is about to leave the screen just based on how long they've been looking at certain elements or what words they've highlighted, whatever metric you want to use. You can use that to predict user behavior. Then, what we'll talk about a little bit more is how you can use these neural networks to create a more custom interface. So, you can predict what colors a person might like, or what words a person might want to see on their page. You can get pretty crazy with this stuff.
You can actually do that in real time?
You can. It's tricky, and it's not always the most efficient, but if you wanted to, yeah. And then, of course, you can use it to find areas of improvement. So if you have people trying to hack your website, you can check for like malicious user behavior. Maybe somebody keeps trying to type SQL scripts into your input boxes. You can check for stuff like that. You can look at how long people stay on a site and do some great A/B testing, stuff like that. So now let's talk about TensorFlow, JS, not the C one or C++ one. This one is the dominant machine learning library in JavaScript. So there's another one that I really like called Brain.js, but it does not have nearly the market share of TensorFlow. And you guys know this is a Google product. And pretty much what it does is it gives you a way to take all of your fancy machine learning logic and knowledge and turn it into something that can work on a user's GPU. You can actually train a model in the browser using someone else's stuff. It's kind of cool, honestly. It takes a while to get used to. TensorFlow has its own like syntax and language it uses. So you really have to know the machine learning terms to understand how to program with it. There is a bit of a learning curve, but once you get it, oh my gosh. They have so much stuff built in that you can literally just plug and play and it's good to go. So now we'll get into the fun part. How do you decide what you want to do with your machine learning project. So one way you can decide which features to use, and features are going to be the same as inputs. So remember the node layer that I showed you earlier and it had the inputs? This is what features are. So to choose what features to feed in, you need to really ask yourself, what is going to add the most value for a user? Because there's some stuff that we like to get into that really doesn't matter. They don't care that the fancy math is there. They don't really care about the programming. They want to know what difference this is going to make for the way that they use your application. And then how are you going to get the information you need from a user? So are you going to go somewhere and buy data? Do you already have data? Are you going to try to get the user to give you data, or are you just going to take it? We'll talk about that in a minute. And then what are you trying to predict? So are you trying to figure out if your users are part of a malicious hacker group and cluster them in that category? Are you trying to figure out, I don't know, what colors they like? If you haven't guessed, we're going to use colors. Are you trying to figure out what you can do to keep them using your application longer? So you need to know what you are looking for with that data, or else it'll be really hard to come up with a model to train. Because the main thing is you have to have a sample set of data that matches up with the inputs. So to train a machine learning model, you have to give it inputs and you have to give it outputs. That's how it figures out, okay, if I see this value, that means it's probably going to be related to this value. Or a more concrete example, if I give the model, let's say, the square footage of an apartment and the price of rent, what location is that going to put me in? Or how can I use that data to predict the square footage or price of other apartments in the area? So make sure you know what you're trying to figure out. And then, again, will they care if you make this update? A lot of things that I've noticed in software is just that sometimes the users are kind of on the back burner when it comes to us getting through sprints. So it's important to make sure you take some time to really think about the user, because at the end of the day, that's why you're writing the code. Now, the fun part. We're going to get into some code. So I'm going to walk you through how you would set up a TensorFlow model, train it, and get predictions from it. So first thing we're going to do is train the model. Okay. So just for this little demo, oh, can you guys see that thing? Minimize some stuff so I can make that bigger. Oh, it's smaller. Okay, can you guys see that okay? Good. Alright, so I'm setting this up on the server side just because this was a little demo project I was kind of playing around with. But you can set it up on the client side. That's where you could take advantage of using like somebody else's GPU. But you guys are probably familiar with Node? Yes? Yes. So you go through the regular setup of the server, and blah, blah. Now we get to the fun part. So this is our training data, the input for it. And what we have, these are just some scaled RGB values. So depending on what algorithm you decide to use for your machine learning project, you might have to scale your data, and I'm pretty sure you can tell this is just fake data, so that I could train this model. And what we have here, we've set up the TensorFlow, so we have that library in here. And basically what we're creating is this tensor. So in TensorFlow, that's just a fancy word for an array of arrays. That is what we have made here for our input, And as you can see, these are in value of in order of RGB values. So we know that. Then this is what I was talking about with having some output data to train. So it's another tensor. And this time, I kind of made up these metrics, so nothing is really hard and fast. You can change it around, do whatever you want with it. But I made it so you can predict the level of darkness, neutrality, and lightness that a person likes in the colors on their screen. So what this is, it basically maps the RGB values to a certain dark, neutral, light percentage. And here, we set up our model. You can do sequential. It's probably the most straightforward if you're not really familiar with machine learning. Until you really get into the stuff like recurring neural networks and some of the other fancier algorithms, I would suggest starting with sequential just because it's sequential. It goes in order that you give it things. So the first thing we do is add a layer to our model. And what we've done here, again, this is a really simple layer. So this is one of our nodes, and you can get fancy and do different types of math things with it if it would show them. Oh, there we go. So you can do some average stuff, batch normalization, whatever. But we'll keep it simple for now. And what this units 3 means, this is what I mean when I say TensorFlow takes a while to pick up because their syntax is weird. But this just means you have 3 hidden layers. So when I talked about deep learning, these give you those extra layers. So the dense function does some crazy math, and it uses these layers to know kind of how deep into the training of the model it should go.
The deeper you go, the more accurate the results are? Okay.
You have more accuracy, but it takes a lot longer to train.
Okay.
And then this input shape is just like our array rows? Yes, the number of columns. Rows, columns. I forget because that stuff is weird. But then we come down here to actually do some kind of statistics on the model. So we're saying, hey, while you're calculating the error for each iteration of training, we want to use the mean squared error function. That's it. And then to optimize it, we're doing some kind of gradient descent algorithm. Now this is the fun part, where you actually get to train the model. And what you do, you call the fit method, you pass in your inputs, and you tell it how many times you want it to run. So you can decide that you only want to train it for 500 runs. That means it will go through this model 500 times and try to predict what values will come. So after you train it, or fit it, then inside, because of course we have promises, once that's done, you can go ahead and predict something. So what I've done here is just like a little demo, and basically we just passed in a random input to see what kind of output it'll give us. So I said, this is the RGB value, and this is how the tensor knows what shape of array structure it's going to be working with. And we just print it to the console. So let me show you what that looks like. So everything that I've talked about up till now leads up to just this, these values down here. So those are the predicted dark, neutral, and light values for this RGB value that I passed in. Everybody follow me so far? Okay. So down here, got a couple of endpoints. Okay. So now I'm going to talk a little bit more about the front end side so you guys see how you actually use this together. And again, this was just a little quick app, so please don't judge me. So to start with, we just set an initial state, give it some light, dark, neutral values, set up some bindings for some functions, blah. Then down here is probably the most important part. Let me minimize this again. Okay. So down here we have the component that we're going to show the user. And this is what it looks like. Just something really basic. But what this does is we pass in the light, dark, neutral values, and it's going to change the background color for that orange part and that little green bar you saw at the top, just by changing the alpha value, because we don't want to throw the user off too much, even though you'll see. So every time that a user moves their mouse over the screen, we're going to record those movements and put them, here we go. So until there are at least 12 new data points, we're just going to start pushing them to an array. So for the first 12 times the user mouses over the screen, we'll pick up the RGB values for that background color that they're over at the moment, and we will send that back into our model, well, back into our server, and we'll call this. And basically what's happening here is we get the user data, we turn it into something we can use. So TensorFlow does not like null values in training data. So I went ahead and zeroed those out, made a new input, made a new output, and trained the model with this new data. So this new data is specific to the particular user. That means pretty much anybody who wants to be on this web app will get different background values based on where they hover over. And we go through the same training process, all that good stuff, and then we finally send the new predicted values back to the front end, where they will update the page right in here. The component did update, so we'll give it those new alpha values. Let me show you what this means, because now we're in the fun part of using the model to make updates to the DOM. So, oh no, we did it without me. Okay, so we've got some values. I'm going to mouse around a little bit, and boom, it changed. Woo! This is the magic of machine learning. So, for a lot of people, they don't really like their websites to be really bright. I'm pretty sure a lot of you use dark mode on a lot of things. But imagine if your website or the app you were on would just adjust to the right hue automatically. So that's kind of where this is leading into. Something bigger that will adapt to a user without a user having to do anything. Because that's what we want. We don't want to do things. But we'll run it again. And you see it's only 2 colors, so get about the same output. Okay, so now I'm going to get into the key takeaways. The main thing that I really hope you got from this is to look for really uncommon ways to implement machine learning. It doesn't have to be about hard data crunching all the time. You can do fun stuff with it. You can make games, you can make UI components, you can maybe even make that GIF, whatever you want. And then TensorFlow, again, it takes some time to get into, but when you really do, it is so powerful. And if you're interested in more of the hard languages, not JavaScript, if you want to try this in, I think they have C and C# versions of TensorFlow, if you want to get more into that. And then, at least with anything we have that's user-facing, try to improve that UI, UX as much as you can on an individual level. That's one of the reasons why machine learning will be so important in web development, because everybody expects everything to be tailored just for them. So let's give the people what they want. And yeah, that's my talk.
Do you want to take some questions?
Sure.
We have time for that.
Okay.
So
Yes.
any questions in the attendance?
Yes.
Have you used these techniques in a project, a real project that you?
Not
did?
in production.
Okay.
People are afraid of it right now.
Yeah. And you mentioned that using the GPU on the web, is that something you can do with the web, like leverage the GPU on the client?
Yep.
How does that work with
So-
TensorFlow?
Basically, what you can do is set up TensorFlow in the front-end application so that whenever they trigger an event or something, it'll go ahead and train the model in the browser.
Okay,
There's like some hook stuff you have to do to get into the GPU, but
but it's possible?
Yeah.
Okay, that's cool.
Do you need the user's confirmation to do that, or is it transparent to the user?
it depends. So for something like changing colors,
Mhm.
no. But if you were going to do something with their actual personal data, then yeah, you would probably want to get their approval for that. Yes.
How much is the performance hit if you have this in the client side?
Well, that goes back to how long you're training the model and how you're calculating the error on it. So if you want a really, really small error, that's definitely going to slow it down because the model has to go through more iterations to train it. So it kind of comes down to finding that balance between how accurate you need your results to be and how much performance you have to spare. But I know once you get it hooked into the GPU, it doesn't make a whole lot of difference,
Right.
but it's still a little noticeable.
What about on the initial download, like getting all those node modules into the browser?
Yeah, that initial download takes a while. It might take maybe like 20 to 30 seconds. So that's a little slow, a lot slow. Any other questions? Yes.
So when the person moved the mouse and you had enough data, it called the server, it trained it, and then it predicted. But let's say you wanted to train just once, okay, maybe not specific to every user. So you want to train it once and just use that model for all the users, right? How would you persist that model?
So one way, actually that's a really good question. So really until you retrain the model is the same. Nothing about it changes. But if you wanted to just do it what, one time per user or
Right.
one time
Like if
period?
you wanted to train it for hours, say once,
Mhm.
you know, and then just use that model, is there ways to like somehow persist that model and then just
Well, I think it's just an array, so
Yeah.
wherever you want to stick that array of numbers, I think you can do that.
That is pretty much it. So if you just wanted to train it in the background for hours, as long as it's on the server side,
right?
that really won't be a problem.
So you did, I think, a linear regression or something. How do you know what model? There's so many different models that you can use, like random forest. How do you know at which point, okay, this is a good model for me to like use? How do you go about selecting?
So one way that you can choose like the algorithms you want to use for your models is to look at the performance. So it's one of those, it really depends on the project. But for example, something like, let's say you're trying to detect malicious users. So that's just straight clustering. So you would look at clustering algorithms. Or let's say you wanted to do something where you predict housing prices. That would be more along the lines of like the linear regression type stuff. It comes down to what exactly you're trying to apply the model to. And then from there, you can look at like how fast it'll train the model, how accurate it is in that speed, because each algorithm has different performances, but a lot of it boils down to like, what am I using this for, and then you just pick a group of algorithms and kind of test with them.
And that comes with experience, I guess, you know, just
Yeah.
trying out, yeah.
You just have to try them out
Right.
until you find something that fits your particular model.
Right. And like, let's say that you had zip code was part of one of the features that you wanted.
Mhm.
How do you convert that into a number as part of an array?
So that will actually probably get weighted. So if you have a zip code or something, you could say the zip code affects the model this much. Something, does that make sense? You give it a certain weight. So you could say like, this zip code has a weight of 3. That's how big of an impact it has on the model. And you could say something like, the square footage has a weight of 5.
Right.
So that's how you would handle that. Any other questions?
I was gonna ask, just to follow up with his point, is there like a resource that we can get access to kind of describe, this is what you're trying to do and this is the best model to use for that particular use case? Is there, or a collection of resources for something like that?
I actually do have one online class I really like.
Mm-hmm.
Are you guys familiar with Coursera? Yeah. So there's one on there, I think it's like machine learning for everybody, something like that. And you can go through, they have all kinds of code examples and how to get through the different algorithms.
Okay.
Yep. Anything else?
Is there, are some of the cloud providers providing this level of service on their platform as a service, or their?
I know Azure and AWS have some machine learning services,
Mhm.
and I know they're a lot simpler to use than TensorFlow, but I haven't really gotten too deep into them.
Okay.
So a lot of people that are using, that say they're doing machine learning, they're not necessarily are getting into the calculus and the really complex stuff. They just use it in libraries,
Mhm.
right?
See, that's one thing I kind of don't like about the machine learning community right now, is they make it seem too complicated. A lot of machine learning that us as software engineers will do, we're not really going to be in the math. They have libraries and services for this that we can just plug in. But if you want to get more like accurate or more performant, then you probably need to jump into some math or get somebody else to. Anything else? Oh, okay. I hope it was useful.